we're moving on to 6.5b, just the second video here for calculus. And we have this graph of velocity, and we have to answer a few questions for position. Now, pay close attention to the directions where they say that at t equals 8, we're starting out at 12. I guess I shouldn't say we're starting. It's just an initial condition. I know it seems weird that they would give you the initial condition halfway through, but we can still work backwards, I guess, so to speak, of saying, oh, well, if we do p of 8 plus the integral from 8 to 3 of b of t dt, that will give me the answer for p of 3. Now, this is how I do it. You don't have to do the problem my way, because for some of you, it might make more sense to go from 3 to 8. Well, then this has to be p of 3, and then over here is p of 8, and then you just subtract over, which is the same thing as what I'm about to write out, because if I want to switch my bounds, I change that plus to be a minus. From 3 to 8, b of t dt equals p of 3 still. So there's so many different ways of doing this problem that I don't want to just say you have to do it my way. Because then from here, I would just create some boxes in here, triangles, I guess, and figure out the area of each piece. Like this, from 3 to 4 is a width of 1 with a height of 5, so that area is 5. And then a triangle with a width of 2 and a height of 5, well, half of 2 times 5 would still be 5. And then this area, now remember it's below the x-axis, so it's got to be negative. Half of 2 times 2, if I'm reading this correct, would be area of negative 2. So 5 plus 5 is 10, minus 2 would be 8. So 12 minus 8 will give me 4 for that value. Again, you might think of this a little bit differently, kind of like how the answer key thinks of it. But yeah, it looks like pretty much the same work. He just kind of goes through. It looks like he uses the trapezoid formula again, which I think you know me by now. I prefer breaking it up instead of doing the trapezoid, but it does work. So that is up to you. As I move on to the next one with acceleration. Now remember, acceleration at 5 seconds is equal to v prime at 5. So as you look at 5, it's basically saying, well, what's the slope? Well, as I'm reading this, it looks like it's going down 5 units, right to, I'm just picking 2 points on that line. Yeah, I would commit to that. Now, as far as units go, I don't know if it even gives you any, yeah, here we go. It gives you units and velocity as feet per second. So if they ask for units, acceleration, you would have feet per second squared, feet per second if you're used to that language. This is the same thing. So then as we look at the next one, what's the net distance the particle moves from t equals 0 to t equals 10? It's just saying how much has it changed. So this question is just from 0 to 10 of v of t dt. We don't need the initial condition because we just want the net. Who cares if you start at 100 or if you start at 200? It's all relative to this problem. Now what I would do is, like it looks like this -2, I would just confirm that this area over here is also -2. This looks like this area is exactly the same. I would just confirm, though, that it is exactly the same. So if I were doing this problem, I would make sure that these are the correct answers. And if they ask for units, it's distance. So we're taking away a second. Like these units is what I'm talking about. So it becomes 16 feet. And just confirming with the answer key. He worked through it a little bit better than the way I worked through it, but that's it. And scrolling down, the difference here is total distance traveled. You might want to practice using the notation from 0 to 10 of putting in the absolute value, because even though that little piece where we went negative below, it was still moving. So it makes more sense then that you I guess essentially what I'm doing is taking this area that was below the x-axis, let me change colors, and I'm flipping it above the x-axis. And so now this area right here is positive 4. So it makes sense that the total distance would be 20 plus 4. I'm trying to explain why this is absolute value. Anyway, the final answer there is 24 feet. And I really, really hope that makes sense. If it does not make sense, please, please, please bring your questions to class so we can get through it. Moving on to the next one, we're looking at velocities in meters per second, moving along the x-axis, t is in seconds. So if we were answering this question, what does the value of the integral from 0 to 18 of v of t dt represent? I think you'd be fine to say that it is net distance, or you can say displacement. From t equals 0 seconds, you always want to give context, to t equals 18 seconds. And the answers that we get will be in meters. So we're just taking away a unit. Taking away a time unit, I guess I should say. Which this guy kind of explains a little bit different. So what about, I would hesitate for you to say this second sentence, just because unless it says the velocity is strictly increasing, I would not say this second sentence where it says because all the values of velocity are positive, then it's also the total distance. Because at no point in the directions does it say it never dips below negative. Like maybe at 14 seconds you get a negative velocity. So I would hesitate to say that second sentence. Let's get back to the notes. Now we can approximate. Okay, we can only approximate because we don't have an exact value up here. So that's why they give us this left Riemann sum with 6 subintervals with equal lengths. Well, it makes sense that they ask for 6 subintervals because there's 1, 2, 3, 4, 5, 6, and they have equal lengths. So because they're equal length, what you can do is you can factor out a 3. But all I'm really doing is doing 3 times the leftmost number. So that would be 2.3. And then plus 3 times the next leftmost number, 2.7. 2 plus 1.3 plus 1. I should have given myself more room. Yeah. 1, 2, 3, 4, 5, 6. Yep, that'll do it. And because we're taking away whatever answer we get, we need to make sure that we're in meters. I don't know if they would let you use a calculator on this type of problem. So feel free at this juncture to use a calculator. And we get 33 meters. Now notice the difference for the right Riemann sum is that we are not starting furthest to the left. We're doing the right number. So basically what it boils down to is I'm going to take away 2.3 and I'm going to start at 2.7, 2.0, 1.3, 1, 1.7, and I'm going to include 2.1, which is exactly why the right Riemann sum looks something like that. Now the midpoint is definitely a little bit more work, so you might want to hit pause before I go back to the notes. Because the midpoint, what you want is the midpoint of the x's. So as you look at between 0 and 6, well, halfway between 0 and 6 is 3. So we need to figure out what b of 3 is. And the other piece to recognize is that the width of each of these rectangles is a width of 6. So as I go back to my table, I should have color coded this a little bit better, is we're doing these intervals from 0 to 6, and then 6 to 12, and then 12 to 18, and we want B of 3, we want B of 9, the midpoint, and B of 15, the midpoint. So each width is still 6, so imagine I'm factoring out, but I'm doing 6 times 2.7, and then plus 6 times the next number, which is 1.3, and then 6 times my last number at 1.7. And we get an approximation that might be a little bit better, might be a little bit worse. I'm just trusting the answer key, 34.2. And then we also have this practice with trapezoidal sums, 6 subintervals of equal length. I don't really like how he does it, so I'm sort of hesitant to show you the work. Maybe I'll show you the work and then I'll come back to how I would do the problem. Because oftentimes I find students forget why we have all these times 2 in between. So let me explain how I would do the trapezoidal sum. So remember, the trapezoids, it looks something like this. I should only do 1. But anyway, the formula for a trapezoid is 1/2 times the width. And since we're back to 6 subintervals, each width is 3. Each width will be 3. And then times the height. Well, the height of the first trapezoid, and again, I should have color coded this better, would be the sum of 2.3 and 2.7. And imagine for a second I factored out the 1/2 and the 3 again, because then the next trapezoid would have heights of 2.7 and 2.0 plus 2.7 plus 2.0. And this kind of explains why the answer key had 2 2.7s. And as I get to the next trapezoid, well, it's got 2.0 and 1.3. And I think you are starting to recognize why there's 2 of each of these in the middle. And as we continue to do 1.3 plus 1.0, and then 1.0 plus 1.7, and 1.7 plus 2.1, it makes sense why we finish without a double on the first and a double on the last. So I'm going to just kind of put a dot, dot, dot. The pattern continues until we get to that. I already forgot what it was, 2.1. So let me go back to the answer key just to give you the final answer of 32.7. Again, if this is not making sense, go ahead and write down your questions and then bring them to class. And because I'm looking at the time, I really don't want to make a third video. I think I'm just going to explain letter F, the average acceleration. Well, when you see average anything, you should be thinking about a slope formula, a difference quotient. Well, average acceleration is the difference quotient for velocity from 3 to 9. It makes sense to do v of 3 minus v of 9 over 3 minus 9. So as you work through that, the average rate of change on that interval is negative 2.33 meters per second squared. So according to the mean value theorem, this average acceleration should be approximately equal to some value in that interval. I don't know if I would commit to exactly v prime of 6, but it is approximately equal is fine. And I like how this author goes back and forth between these theorems so you get good practice as we move forward. So at this point, you should be ready for the homework. And please, please, please bring any questions you have to class. I'd love to answer them.